Our last speaker of the session is Dr. Ge-Hoon Do from KISTEP. He is the Director of S&T Analysis and Indicators Division of KISTEP. He is mainly responsible for R&D survey and analysis of S&T innovation indicator. He has also served as the Korean delegate of OECD NEST. He earned PhD in International Business and Management from Tohoku University in Japan. Today, he will speak on evaluation of national and regional science and technology innovation capacity. Please welcome Dr. Do.
Good afternoon, ladies and gentlemen. Thank you for attending my presentation. I'm very happy to be here in front of you all. Today, I would like to present evaluation of national and regional science and technology innovation capacity. My presentation, there are two parts of my presentation. The part one is composite S&T innovation index. And part two is about regional composite S&T innovation index. Then this leads us to cost firstly. As you know, in the knowledge-based economy, science and technology is very important too. And also it has been becoming the core driver of national competitiveness. Accordingly, an accurate measurement and evaluation which will enable us to precisely capture the current state of science and technology is a key necessity. KISTEP aims to compare the science and technology innovation capacity among 30 OECD member countries by developing indicators and evaluation model. The result helps us to define strengths and weakness of science and technology. It also suggests a proper policy implication needed for the enhancement of science and technology. KISTEP is indigenous evaluation model in Korea, monitoring the science and technology innovation capacity qualitatively and quantitatively at the national level. Sorry. The main idea of KISTEP is based on the national innovation system. As you know, we tried to conduct comparativeness review of the overall process of innovation. And we also conducted a systematic approach that regard active interaction between the elements of a process as being a decisive factor of the national science and technology innovation capacity. In 2004, we start to develop the indicators which can measure the innovation level by countries. After the pilot test, the KISTEP was developed and the evaluation of science and technology innovation capacity for 30 OECD member countries was started since 2006. This slide shows us the overall frame of KISTEP. Based on the National Innovation System Framework, the innovative process consists of 5 dimensions of innovation: resources and activities, network, and environment and performance. Each dimension has several sectors, and we consider the interaction effect between input and output sectors. Also, each sectors have some detailed indicators. The resource dimensions has the 3 sectors: human resources and organization and knowledge resources. As I mentioned before, each sector has the detailed indicators. Among the 31 detailed indicators, we developed 27 quantitative data and 4 qualitative items. Next slide shows us the active dimensions. Active dimensions has 2 sectors: R&D investment and entrepreneurial activities. Also, each sector has several detailed indicators. And then network dimensions has also 3 sectors: triple helix corporations and technological cooperation and international corporations. It also has several detailed indicators. And then environment dimensions has 3 detailed sectors: support system and physical infrastructure and cultural. It also has several detailed individual indicators. This also shows us the performance dimensions. Performance has 2 kinds of sectors: economic outcome and knowledge creation. Each sector has also the individual detailed indicators. All right, then let's move on to the next slide. We collected data from the internationally recognized statistics and materials. Data just like OECD and USPTO, IMD, etc. We calculate the weighting of calculating at the level of sectors, and each dimension is calculated the sum of sectors. Also, the sector score is sum of the indicators. We developed the standard to calculate the standardization. Is we use the fuzzy set theory. It is mainly focused on AHP. Then let's move on to the next slide. This shows us the result in 2014. Among the OECD, 30 OECD countries, the US ranked first place position with a score of 20. And second second ranked is Switzerland, and Japan and the third ranked. And Korea is seventh ranked. As you know, China is emerging country in the not only in the field of industry but also that of science and technology innovations. So we tried to calculate the index, include China. Among the 31 countries, including China, China ranked 14th place position with a score of 11 out of 31 points. This is China's score. And then let's go to the part 2. Part 2 is about the Regional Composite Science and Technology Innovation Index. Because the main frame of our cost is similar to the COSTI, so I'd like to skip the detail explain about it. We mainly focused on the 16 regions in Korea. Korea has now 17 the province, but this is the result of the 2014. We cannot conclude the all region because the data restrictions. Almost the frame is similar the COSTI, and between the interaction between the input and the output sector, the dimension is our COSTI has 5 dimensions and 13 sectors and 31 detailed indicators. This table shows us the detailed indicators. Dimensions and sectors are very similar to the COSTI, but very different from the indicators level. This is the table I mentioned before. Yeah, okay. This frame is also the shows us our COSTI, almost the frame and the method of calculation is very similar to the COSTI. This is the result of the our COSTI. In 1914, the Seoul is the first ranked in Korea. The second ranked province is the Gyeonggi, and then Daejeon. This kind of result is very important for the policymakers. We make the science and technology basic plan every 5 years. The policymaker referred this result to make the basic plan, and every year we check the result. Okay, thank you for your attention.